everyone! Today we'll solve a problem which I found on their website Braille quite a while back, but didn't solve until today, and it has a really nice answer. So, let's see what the problem is. We have an acute isosceles triangle which has the same radius and circumradius as a 3, 4, 5 right triangle, and we want to find the secant of one of the base angles of that triangle. So, as a refresher, the radius of a triangle is the radius of the circle of a triangle, which is simply the circle tangent to the three sides of the triangle, and the circumradius is the radius of the circumcircle of a triangle, which is the circle going through the three vertices of the triangle. So, it might be a good idea to first calculate the radius and circumradius of our 3, 4, 5 right triangle. And let's do exactly that. So first, we will draw the 3, 4, 5 triangle and the circumcircle and an circle. This might take a long time. Okay, so this is my attempt at drawing an circle, and let's get started. So we know that this side is 3, this side is 4, and this side is 5. Let's calculate the circumradius because it's easy. Because the diameter of our circumcircle, since this is a right triangle, is simply the hypotenuse of the right triangle, which means the radius will be half the hypotenuse. Therefore, our circumradius, which we will call R, capital R, will be 5 halves. And then let's calculate the radius of our triangle. So let's call this radius little r, and since it is tangent to all the sides of our triangle, all of these will be right angles, and this is also R, I forgot to mention that. And since right here we have three right angles in our quadrilateral, because the sum of the angles in the quadrilateral is 360 degrees, this will also be a right angle, meaning we have a rectangle, and since two adjacent sides are equal, it will be a square. Therefore, all the sides of that square will be equal. So this means this will also be R, and this will also be R. But then, this will simply be 4 minus R. This will be 3 minus R. And by the principle of equal tangents, this will be 3 minus R. And this side will be 4 minus R. But then, the whole hypotenuse is 5, which means we can get the following relationship, the following equation for our radius, namely 3 plus 4 is 7, minus the 2 r's together will be 2r is equal to 5, and then solving for r yields r equals 1. Therefore, our radius is equal to 1. So, let us now draw our isosceles triangle with the given information. Okay, so it was a little bit better than this one, but, well, I have never been an artist. I am a mathematician, a wannabe mathematician, that's a natural mathematician. I haven't got my bachelor's degree yet, which you can easily see. Okay, so let's get back to the problem. So we know our radius is 1, so let's draw this in. So all of these will be right angles. Okay, and let's call the base angle alpha, which means this will also be alpha. And basically what the question asks is what is the value of secant of alpha. So then let's zoom in on this quadrilateral right here. Like this, I will redraw it right here with, as I said, my magnificent artistic abilities. Okay, so we know that this is a right angle, this is a right angle, this is one, and then we know that by the principle of equal tangents that this is equal to this, so let's call them both n. And also by the principle of equal tangents, this is equal to this. But since those two quadrilaterals are the same, these will also be n. So now this is n, this is n, this is alpha, and then since the sum of angles in the quadrilateral is 360 degrees or 2 pi radians, and our two right angles already take up pi radians of that, the remaining angle right here will be pi minus alpha. And then we will insert the following line segments connecting these two opposite vertices. And then we'll call this line segment, I don't know, mu, let's say. Yeah, there's background noise outside my house, sorry for that. So we have two triangles in which we can apply the law of cosines. So in the first triangle, we have mu squared is equal to 1 squared plus 1 squared, which is 2, minus 2 times 1 times 1 is 2. And the cosine of pi minus alpha is simply minus the cosine of alpha. You can easily verify that using the unit circle or something. So the minus will cancel out, so we'll get 2 plus cosine of alpha. But this is also equal to, comparing with the second triangle, n squared plus n squared, which is 2n squared, minus 2 times n, which is 2n squared times cosine of alpha. And now we can simply divide everybody by 2, giving us 1 plus cosine alpha, which is factoring out the n squared term. We get n squared times the quantity 1 minus cosine of alpha. And then let's divide both sides by 1 minus cosine alpha. So we'll have 1 plus cosine alpha over 1 minus cosine alpha is equal to n squared. And then I would like to make the following observation. So we know that the tangent squared of alpha is nothing but 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. And now if we substitute in alpha, if we let alpha go to alpha over 2, we get tangent squared of alpha over 2 will be 1 minus cosine alpha over 1 plus cosine alpha. Yeah, as I said, there is background noise outside my house, which is out of my control, sorry for that. And then taking the reciprocal, we get that cotangent squared of alpha over 2 is 1 plus cosine alpha over 1 minus cosine alpha. But this is exactly what we have here. Therefore, our n squared will simply be cotangent squared of alpha over 2. But then we'll take the positive square root on both sides so that things make sense. We'll get n equals cotangent of alpha over 2. So let's insert that into our diagram. Cotangent alpha over 2, cotangent alpha over 2, cotangent alpha over 2, and finally cotangent of alpha over 2. And now I'd like to focus on this quadrilateral right here. But first, let's find some angles. So we know that the sum of angles in the triangle is pi radians, And in this isosceles triangle, we have 2 alpha already taken, which means this angle will be pi minus 2 alpha. And then we know by the sum of angles in the quadrilateral that this is simply 2 alpha. So now, this quadrilateral is kind of similar to this. So let's change the information in this zoomed in quadrilateral to this zoomed in quadrilateral because I'm too lazy to draw it again. So our ones and ones will be preserved, but this angle shall now be 2 alpha. This angle shall now be pi minus 2 alpha. And then by the principle of equal tangents, we'll call those two sides n, which means these will now be m. And this segment can no longer be called mu. So let's call it, I don't know, what could we call it? Sigma. Okay. So as we did before, we will apply the law of cosines in these two triangles. So we have that sigma squared, our variance, no just kidding, will be 1 squared plus 1 squared, which is 2 minus 2 times 1 times 1, which is 2 cosine of 2 alpha. But this will also be equal to m squared plus n squared, which is 2m squared, minus 2 times m squared, which is 2m squared. And then cosine pi minus 2 alpha, as we said earlier, will be simply negative cosine 2 alpha, so let's put that in. And then we can simply divide everybody by 2, which leaves us with 1 minus cosine of 2 alpha is equal to factoring out the m squared of 1 plus cosine 2 alpha. Dividing both sides by 1 plus cosine 2 alpha, we get 1 minus cosine 2 alpha over 1 plus cosine 2 alpha is equal to m squared, but as we see right there, this is equal to tangent squared alpha. Therefore, taking the positive square root on both sides, we get that n is equal to the tangent of alpha. So let's draw that into our diagram. So this will be the tangent of alpha, and this will be the tangent of alpha. And now that we have all the information we can extract from the incircle, let's focus now on the circumcircle. So let's erase this so that the picture is not so cluttered. And let's see. We know that the circumradius is simply 5 halves. So let's draw this thing in like this, 5 halves and 5 halves. So let's see. We know that an isosceles triangle is symmetric about its height going from the vertex opposite to the base, and that in radius going from that circumradius going from the circumcenter to this opposite vertex is exactly along the height. So we can prolong this, and this will divide the height in 2, and those two pieces will both be of length cotangent alpha over 2, as we saw earlier. And then the height going from the vertex opposite to the base is also the angle bisector of that vertex. So this will be pi over 2 minus alpha. And then since this right here is an isosceles triangle, because those two sides are equal, the opposite angles will be equal. So this will be pi over 2 minus alpha. But then alpha minus pi over 2 minus alpha is 2 alpha minus pi over 2. So this angle will be 2 alpha minus pi over 2. So let us now focus on this right triangle. So we know that, we just draw this again. This side right here will be cotangent alpha over 2. This will be 2 alpha minus pi over 2. And this will be our circumradius 5/2. And now we can use basic trigonometric ratios to find that the cosine of 2 alpha minus pi over 2 is simply cotangent alpha over 2 over 5/2, which is simply 2/5 cotangent alpha over 2. But then, let's see. Cosine of 2 alpha minus pi over 2 is simply, because cosine is an even function, cosine of pi over 2 minus alpha, minus 2 alpha. And then this is simply sine of 2 alpha, which is 2 sine alpha cosine alpha. And then dividing both sides by 2 and multiplying both sides by 5, we get that cotangent alpha over 2 is equal to 5 sine alpha cosine alpha. So now we have a trigonometric equation in alpha which we can solve after we erase the board. And now I've practiced snapping my fingers, and let's see if it works. Okay, so it worked. My thousands of minutes of practice have finally did something. So now as we said earlier, we have that trigonometric equation in which we can solve for the secant of alpha. So first, I would like to remember that what we wrote earlier on the board was that the cotangent of alpha over 2 is nothing but, let me just write this, 5 sine alpha cosine alpha. We have written that cotangent square of alpha over 2 is simply 1 plus cosine of alpha over 1 minus cosine of alpha, taking the positive square root on both sides. We get that this is equal to the square root of 1 plus cosine alpha over 1 minus cosine alpha, which means squaring both sides, we get 25 sine squared alpha cosine squared alpha equals 1 plus cosine alpha over 1 minus cosine alpha. And now I would like to introduce a substitution, namely, let u be equal to cosine alpha, which means du will be, no, just kidding, we are doing integration, which means that our sine alpha, our sine squared alpha, will be, by the fundamental theorem of trigonometry, 1 minus u squared. So let's substitute everything in. We get 25 times 1 minus u squared times u squared is equal to 1 plus u over 1 minus u. But then we know that 1 minus u squared is simply a difference of squares, which can be factored into 1 minus u times 1 plus u. The 1 plus u terms will cancel out, and bringing everything to the left hand side, we get that 25 times the 1 minus u's will combine together to make 1 minus u squared times u squared is equal to 1. Taking the positive square root on both sides, we get 5 times 1 minus u times u is equal to 1. Expanding everything out, we get minus 5u squared plus 5u minus 1 is equal to 0. And multiplying everything by negative 1, we get 5u squared minus 5u plus 1 is simply equal to 0. This multiplying by negative 1 is simply just writing the equation nicely. So let us now solve that quadratic equation using the quadratic formula. So our u will be negative 5, which is 5, plus or minus the square root of, okay, so now let's do some mental arithmetic. Minus 5 squared is 25, 4 times 5 times 1 is 20, 25 minus 20 is 5. All of this divided by 2 times 5 is 10. But now, this is our value for the cosine of alpha. So let's see, we have two values. So if you use a calculator, you can see that neither of these values are negative because since alpha is acute, the cosine of alpha is positive, but both values are positive here. And both of these values are less than 1 because cosine of alpha is bounded between -1 and 1. So let's see how we can rule out one of the two, one of the two branches. So we know that our triangle is acute. So this is alpha, this is alpha, this is pi minus 2 alpha, because the sum of angles in the triangle is simply pi radius. But then, being acute means being strictly less than pi over 2 radius, which means for this triangle to be acute, our pi minus 2 alpha must be strictly less than pi over 2. Subtracting pi over 2 and adding 2 alpha, we get 2 alpha is greater than pi over 2, which means alpha is greater than pi over 4. And now if we take a look at the unit circle, like this, it looks more like a potato, but let's not care about that. This is our alpha equals pi over 4, so the cosine of pi over 4 is square root of 2 over 2. And now, if we draw a larger angle, like this, the cosine gets even smaller. So this means that for alpha to be greater than pi over 4, the cosine of alpha must be strictly less than the square root of 2 over 2. And then, if you plug both branches into a calculator, you can see that the positive branch is greater than square root of 2 over 2, which means it shall be ignored. So our u will simply be equal to, well, our cosine alpha will simply be equal to 5 plus the square root of 5 all over 10. But we want the secant of alpha, so to find the secant of alpha, we simply take the reciprocal, so secant of alpha will be 10 over 5 plus the square root of 5. And now we will rewrite our answer by rationalizing the denominator by multiplying by the conjugate. So this will be 5 times 5 minus root 5 over 5 minus root 5. So this will be 10 times the quantity 5 minus square root of 5. And then this is simply a difference of 2 squares, which is 5 squared, which is 25, minus square root of 5 squared, which is 5. 25 minus 5 is 20. But then 10 over 20 is simply 1/2, so this will be 5 minus 5 minus. Wait, oh yeah, sorry, I wrote a plus. I meant it to be a minus, so this will be plus like this. So this will be 5 plus the square root of 5 all over 2. But then we can rewrite it to be even nicer. So if you're watching this channel, I hope that you know that 5 is nothing but 4 plus 1. So let's substitute that in. So this is equal to 4 plus 1 plus the square root of 5 all over 2. But then we can break this fraction into 2. So this will be 4 divided by 2 is simply 2. 2 plus 1 plus the square root of 5 all over 2. But what is 1 plus the square root of 5 over 2? It's exactly 5, the golden ratio, which means our answer is now 5 plus 2. This is a really nice answer, as I already told you. So I wonder if this triangle should be called the second golden triangle, because the golden triangle, which already exists, has the property that the ratio of the slant side to the base, which is the isosceles triangle, is exactly the golden ratio, and its angles are in the ratio 1 to 2 to 2, which means its angles are 36 degrees, 72 degrees, and 72 degrees. But this triangle has the property that the secant of alpha, which is basically the ratio of the slant side to half the base, is equal to 5 plus 2. This is really interesting. And as always, this is another video. Thank you guys for watching. If you like this video, don't forget to like and subscribe. And I'll see you in the next video. Bye.